Hi everyone, this is a video going through the answers to practice paper A. So this was posted on Friday for you. Hopefully you've had a wee chance to do these questions, to attempt them using your notes as well, since we haven't done these questions for quite some time. Here are the answers to them now. So question 1 is all about fractions. Whenever I'm doing the adding and subtracting fractions, I tend to change them to top-heavy fractions, even though it's not necessary. I will generally do that, but you can leave them as mixed numbers, do your 3 take away 1 to get your whole number, and then 2/5 take away 3/4. You will end up with negatives there and so on, which is why I like to do it the other way. So 3 and 2/5 gives us 17/5. Subtract from that 7/4. We are going to have to create the same denominator, so 20 as our common denominator here, times in the first fraction by 4 and the second fraction by 5. So we've got 35 on top of this first one, 17 times 4, 68. And then we can subtract the two top numbers, so we end up with 33/20. Now that can be your final answer, you don't need to change it to a mixed number, but if you do, you will get 1 and 13/20. Question 2, we can complete this one as well. So we're looking to label our A, B's and C to factorise. This is trinomial factorisation. A is 1, B is 2 and C is -15. A times C is -15. So I'm looking for two numbers that will multiply to give me -15 and then will combine to give me the 2 in the middle. These numbers will be -3 and 5. It has to be one negative and one positive to create the -15, and 3 and 5 will times to get the 15, but -3 is a smaller number than +5, so when I add them together I get +2. Put those two numbers then back into the expression, so x squared with x's minus 3x plus 5x minus 15. Factorise the first two numbers, so it's x bracket x minus 3 plus 5 bracket x minus 3. So we're taking out a common factor of the first two. Remember, splitting this down the middle, keeping the symbol the same. Lastly then, our two brackets are x minus 3, that's our common one, and x plus 5 for our second bracket. Question 4, so I've missed question 3, we cannot do that one. Question 4, express x. No, never mind. Question 4 we can't do either, we'll skip past that one. Question 5 we can now do, however, because we have looked at this recently in Unit 4. So I'm trying to change the subject to R. So I'm going to swap the sides round. Since R is on the left hand side, I just prefer to work with the thing I'm changing the subject to on the left. So I need to undo all of the operations that are surrounding the R cubed in this case. Before I can cube root anything, to undo that cube, I have to get rid of everything that's surrounding it. So I first have to isolate the R term, then I can start to root both sides. So add 5 first of all, gives me R cubed B equals P plus 5. That's R cubed times B, so divide by B on both sides to be left with R cubed. That equals P plus 5 all over B. And then, as I mentioned earlier, to undo a cube, we have to cube root. Now we've seen this recently with the volume similarity questions. We were working volume down to length, so we had to cube root. So we've got to cube root this as well. Big root, make sure the 3 goes there. If it's a cube root, it's got a 3 at the front. P plus 5 over B inside. That 3 there has to be quite small. It cannot be a big 3, because that would be 3 times your root. So to cube root, a little small 3 attached to your root. Next, we have got to identify this graph. So we're told here that part of the graph y equals cos bx is shown in the diagram. So we know it has to be cos, and we've got to work out the value of b. Now b tells us how many times the graph appears in 360. So a cost graph looks like that, okay, which means this here is one cost graph, stops at 120. So one's 120, if I were to draw another one, that's another 120, so that's up to 240. Another one would take me to 360. So there are 3 graphs in 360, which means B equals 3. You had this one in your December course assessment. There was A and B, so you had to work out how much it had been stretched as well. In this case, it's just how many there are. Question 8 we can also now do, since we've done Unit 4. We want to lay these equations on top of one another, and we'll be able to find out a value for x and y. So 2x plus y equals 5, and x minus 3y equals 6. Now, I am going to decide to multiply the top equation by 3 because I've got a plus and a minus in the middle there, meaning that I would be able to add these equations together. So if I times the top one by 3, I get 6x plus 3y equals 15. I don't need to times the bottom equation because I now have 3y and 3y. And since they have different signs, I can add them together. Therefore, I'll end up with 7x equals 21. So x equals 3. Once we have that x equals 3, we have to substitute it back into one of our equations. Sub x equals 3 into one of your top equations. So if you label them 1 and 2, and I'll use equation 1 since it's all positive. Equation 1 was 2x plus y equals 5. X is now 3, so 2 times 3 plus y equals 5. 6 plus y equals 5. Take away 6 from both sides, so y is negative 1. The only thing you want to do now is convert that into a point. So the final answer then, a point is always x, y, so 3, negative 1. Okay? You would get a final mark for writing it in that coordinate point, so please just make sure that you do that 3 minus 1, take it together at the end. Next, we have got to combine the algebraic fraction into a single fraction. Again, you had something like this in your December course assessment. We can use the smile and kiss method to create a common denominator here. So 3 bracket x plus 2, on the top of that fraction, x bracket x plus 2. On the bottom, we're timesing those together. All those lines are representing multiplying. And on the second fraction, take away 5, times that by x, and your common denominator on the bottom. We can combine the top of the fraction. So we've got 3 bracket x plus 2 minus 5x all over x bracket x plus 2, and you should keep working down the way. I've just not got the space, so I'll go up to the side. Multiply out that bracket, 3x plus 2 minus 5x. Where'd that go? There it is. Right, minus 5x. Okay, that's an x on the end. Yep, you can't see it. Fine. X bracket x plus 2. 3x, take away the 5x, gives me negative 2x plus 2 all over x bracket x plus 2. Okay, now that is an x on there, just, there we go. Looks like an x now. Part B then for this question is all about surds. So we've got to simplify each of the surds here and then add or subtract them. So root 18, I'll take that out to the side. That can be split up into root 9 times root 2. So we're looking for a square number that can divide into 18. The square number here is 9. When I square root 9, I get 3, so that becomes 3 root 2. Root 72 can be simplified to root 36 times root 2. Now, if you use any other combination of numbers, any other combination of a square number and something else, you'll be able to simplify it a lot further to get 6 root 2. So the simplest it can be is 6 root 2. if you've used maybe, what could you use? You could use 4 up there, or you could use 9 as well. But make sure you just simplify that root a little bit further as well, whenever you can. So 3 root 2, that should be root 2, not root 3, over that side. Not doing very well with this question here. Right, so 3 root 2 comes from the 18, minus root 2 was in the middle, and plus 6 root 2 from the 72. 3 of something, take away 1 of something, add 6 of it, gives you 8 of those somethings. So 3 take away 1 is 2, plus the 6 gives you 8, with the root 2 attached to the end. Think of them as x's again, the root 2 is just a thing. Think of it as, I don't know, circles, football, something, people. 3 of them, take away 1 of them, add another 6 of them. Okay, on to the paper 2. There wasn't much paper 2 that we could actually do, so I've just copied over, I think it's 4 questions that we've got in here. So the population in a city is increasing at a steady rate of 2.4% per year. Increasing, it's going up. The current population is 528,000, and we want to take this over 4 years. So first thing to do is 100%. What's been done to the 100%? We are adding on 2.4%, making it 102.4%. Changing this to a decimal gives us 1.024. That's our first step for these increase, decrease percentage calculations. Then we are looking to take this over 4 years. So we take our decimal, 1.024, we raise it to the power of 4, and we times it by our original. So 528,000. This can go in your calculator. This is a calculator paper. This starting from now, it's paper 2. So power of 4 times 528,000, and we'll get 580,542.13 and so on. Now we've got to round this. We can't have, for populations, we want a whole number of people. So 580,542 people will be our population at the end of the 4 years. Next question here doesn't require a calculator, but often does appear in the calculator paper. Multiply through the brackets, take the x, multiply through that by each of your terms, so you'll end up with 2x cubed plus 3x squared minus x. Take the 4, multiply that through as well, so plus 8x squared plus 12x minus 4. Again, we saw one of these in the December course assessment. The only difference was that the term in the first bracket, the second term, was a negative, which meant you had to multiply through by the negative as well. So, collecting all these together, we only have 1x cubed. 3x squared plus 8x squared is 11x squared, minus x plus 12x plus 11x, and then the minus 4. Be careful when you're adding these together, that's minus x plus 12, so minus 1 plus 12 gives us the plus 11x. With this question here, we did a lot of these during revision, multiply through the bracket just using our index terms as well. So when we multiply two terms together, we'll end up here with a squared times 2a to the negative a half plus a squared times a. The second part of this is a lot easier than the first part. We will end up, when we multiply the first two terms here, multiply the two front numbers, that's 1 times 2, which is 2. Add your 2 powers, so 2 plus negative a half gives you 1.5, basically 2 take away a half. You can keep that as 3 over 2 if you like as well. We're adding on to that a squared times a, which is a cubed. Generally, there's some simplifying you can do with this question. There's not in this particular example, but just look out for that if you see it in an assessment later on. And lastly, we are using the calculator for this one. Solve the trig equation. So you've got to take away 5 first of all from both sides to get 4 tan x equals negative 5. Divide then by 4 to get tan x equals negative 5 over 4. We are using our cast diagram, so we've got two angles to find. We've got x 180 minus, 180 plus, and 360 minus are the calculations to do within those. Now, when we're looking at this diagram, we are thinking about the fact that we have a negative 5 over 4. So with tan, we normally want to use A and T. Since it's negative, we use the opposite, so it's S and C this time. So we find our one value of x by doing tan negative 1, 5 divided by 4. We need to make sure that we don't put the negative in the calculator, otherwise our calculations will be off a little later on. So that equals 51.3 to 1 decimal place. And we've got to perform the two calculations. So the first one was 180 minus 51.3, and the second one was 360 minus 51.3. That should be a 3 in there, not a 1. Okay, and we pop these in the calculator, that will give us our two answers. So 180 minus 51.3 gives us 128.7, and 360 minus 51.3, 308.7. Okay, so our two answers, x is 128.7 degrees and 308.7 degrees. Okay, that is the end of the worksheet. Hopefully you got some of those, hopefully you're picking up at least parts of the questions when you were doing them on your own. Okay, thank you everyone.